Well, if we start with the oil and gas market, that's a very mature market. The technology revolves around finding new leaks as they form, because no leakage is permissible. The consequences of a leak in an oil pipeline or gas pipeline are very severe. That's been in legislation for a long period of time. If we look at the water network and the water industry, leakage is an acceptable practice. It's an associated byproduct with moving water under pressure around the network, and it has been a regulatory requirement to reduce leakage in the UK since 1997, so it is a mature market. However, we find that the focus on leak detection revolves around finding existing leaks in the district metered areas, which is where the highest use of water is. So what we're doing at Atmos is we're bringing our 30 years experience that we've accrued in the oil and gas sector, which focuses on finding new leaks as they form, and we're bringing that to the water sector, and with a main focus on looking at the upstream network, so looking at trunk mains, where there's a close association with water supply interruptions due to bursts in those pipelines. So we're bringing that sort of technology that we've developed in the oil and gas sector, and we're bringing that to the water industry.
Yes, we can utilise existing instrumentation, but we need to consider the repeatability, the resolution and the data acquisition rate of that instrument. If there's any pre-filtering or pre-dampening applied to that sensor, it can have a negative impact on the system. That's generally why we prefer to use analogue pressure transmitters.
Well, both actually. In a water network, you're going to have your strategically important areas, your high consequence areas, and in those situations you really want an insurance policy, so a 24/7 coverage with a permanently monitored solution, so that as soon as you have a new leak forming, you are aware of it and you can locate it straight away. There are also going to be areas where you have problems with existing leakage. Maybe it's hard to pinpoint where that leak is occurring, and so a portable lift and shift approach can be used in those situations, where you can deploy some instrumentation, you can monitor a section of network for a period of time, find the existing leakage, and then lift up the equipment and move on to the next area. And that gives a water utility the option to find leaks in a more affordable way, while still being able to permanently monitor those important high consequence areas at the same time.
Yes, our leak detection systems can work on plastic pipeline as well as metal pipelines. We also have a vast experience of working on a range of diameter lengths along the pipeline route. We've developed a vast experience in the oil and gas, and in oil and gas pipelines they have very similar characteristics, so we have to deal with variable flow rates, varying pressure, and we also have to deal with multiple injection and delivery points. So when we talk about this type of system, what we need to be able to do is tune the system effectively and also be able to provide the right hardware in the right locations. It's about providing a balancing act between the sensitivity that we can get and also the reliability.
Well, there are a variety of reasons that cause water leaks, and if you first of all look at water consumption from properties that don't have a water meter, since the volume of water used can't be defined, that can also contribute to the official leakage figure. Within those properties as well, you have associated plumbing faults, so that can contribute to leakage. But if you focus on the pipeline network and causes for leakage there, differences in soil temperature and moisture content can make pipes move, and that can contribute to the leakage. You can have fragile pipelines where the material is corroded, lack of investment in pipelines and not renewing the pipelines often enough, that can contribute to leakage. High pressure in the pipeline and improper pressure management can contribute to leakage, and so we tend to find that generally there's a wide variety of reasons that contribute to leakage, and overall, because it's a pressurized environment, the leakage rates are higher because small leaks then turn into large leaks. Well, the same size leak occurring in different parts of the network may or may not be an emergency. Leakage has been a permissible practice in the UK for a number of years. It's an associated byproduct with transporting water through the network under pressure, and so a background leak that occurs in a network might not be considered an emergency. However, if you have a trunks main that bursts and it stops the water supply to a large number of customers, then that would be considered an emergency. Likewise, on the wastewater side of things, the environmental impact associated with any leakage is high, and so that would also be considered an emergency. Well, it's fair to say that actually looking at leak detection across the whole water network, the main focus are in the urban areas and district metered areas. But there is a growing focus in trunks main leak detection, and we find that there are a variety of techniques used. A lot of them are externally based methods, so things like sniffer dogs, aerial drones, satellite imagery can be used to detect leaks. But the most common method of leak detection is line walking. So water utility personnel will walk up and down the trunks main periodically to see if there are any signs of leakage. But it's worth noting that a lot of leakage is undiscoverable at ground level, and so it's quite a basic, line walking is quite a basic method, and so at Atmos we're keen to really promote a technology driven approach to trunks main leak detection that focuses around finding new leaks as they form.
So Atmos have leak detection hardware that completes all the processing of the 60 Hz data internally, so we don't need to send out any of the data externally for processing. So what the device is doing is looking for any new leaks or bursts forming on the pipeline. Once an alarm is generated, that's then sent out in a small packet, and it's processed and analysed within the data portal. By utilising what we call the edge processing, means we can reduce the high costs associated with high resolution data.
Well, any leak detection system needs to find leaks quickly and locate them accurately. In the downstream area of the water network, you have a high population density, and so those customers currently call in those leaks as soon as they occur. But in the upstream network, in the trunks mains, we tend to find that they are closely linked to water supply interruptions for large numbers of people, and we currently don't have any or much instrumentation at all to allow us to identify that leakage. So what we really need is high quality raw data, high resolution data, and that means we need to have instrumentation that has the versatility to be deployed at various areas along the network where we need them to be deployed, and that will allow us to find these new leaks as they form. Another critical area is ensuring that we have a low rate of false alarms, otherwise your operators won't have trust in the system, so that when an alarm event is raised that they actually take action.